Now let's have a look at another situation for the volumes of the solids of revolution when the curve is rotated about the y-axis. Okay, so we have a curve here. Again, I'm actually using a y equal to x squared here, but I'm only using partial curve, and it's rotated by y-axis, and it will actually create a really nice solid that you can see here appeared here. And we're going to use the same approach. We're also going to use the disk method to help us to find the volume as well. So this time we're going to actually slice the disk horizontally. As you can see, the new disk that has appeared here. Now we're going to actually show you what it looks like when you animate it. So we're going to rotate it. You can see on the left hand side, the curve is rotating, and it really creates the solid like a bowl, but please make sure that you know that it's actually not empty, it's not hollow, it's a solid shape. Now we have the cylindrical approach. We cut it into lots of thin slices. Okay, so you just imagine a lot of slices here. So for example, if I change the number of the slices to here, you can see it's actually getting closer and closer to the original shape. So which is why we're actually using the integration here, because integration means you're cutting into many slices and then add them up. And then as long as the slice is getting thinner and thinner, and then you really reach to what the real shape is. Okay, so I hope that you can actually visualize it with your eyes now. So let's go to the right hand side and see what it looks like. So for one slice, the volume is pi r squared h. So the radius of the cross section, which is the radius of the circle r, is actually represented by, on the graph, which is the x value. So you can see from the graph here, from the y-axis all the way to the edge of the curve, which is the horizontal length, is the radius. And the height of the cylinder is actually represented by the change in y value. So therefore we can say the volume is pi x squared delta y. So this is one disk or one slice of the cylinder's volume. Now another information that often the question will give you is where the boundaries are at. So we chose the curve that is starting from this point, and we're going to say A, all the way going up because it's rotated about the y-axis. So they will give you the y boundary. So start from here to here. Therefore, the total volume of the solids of the revolution will be integration of A to B pi x squared delta y. I'm going to change the delta to D. However, you have to be careful. The boundary itself is actually for y values, and you have delta y, which means integrate the function with respect to y. Therefore, this function here must be in terms of y. Therefore, you actually need to rearrange your question so that it will become a function of y. So we're going to write f of y squared dy. And obviously pi is a constant, so you can take the pi out. So it's pi times by integration of a to b, function of y squared dy. So let's have a look at this example question here. Determine the volume of the solid of revolution when the curve y equal to x squared. Y is between 0 and 4 is rotated by about the y-axis. So again, we know y equal to x squared is the parabola, so you can actually still use the left-hand side picture that you can see is currently rotating about the y-axis, so you can actually visualize it very clearly. And I'm going to draw the cylinder that it creates. So technically, we just need to use one side of the parabola. Let's say we're starting from 0, and this is where it stops 4, and this is rotating about the y-axis. Therefore, from here, y-axis all the way to the edge of the curve is our radius, which is represented by x. So I need to know how I can write this x in terms of y. Because y equals to x squared, I can rearrange it, so therefore x equals to square root of y. Because I'm only looking at the positive side, so that's why I'm only worried about this positive square root of y. Now I know my radius, and I know I cut it into slices with the equal depth. Then my depth of each disk will be delta y. So I know the entire volume is starting from 0 to 4 pi r squared, so pi x squared delta y, and I'm going to replace the x with what I got above, which will rearrange it, so square root of y squared delta y. So therefore I can take the pi out, integration of 0 to 4 y dy, and pi times by integration of y from 0 to 4. Now I'm going to do substitution, which is 4 squared over 2 minus 0 squared over 2. Therefore, the final answer is 8 pi unit cubed.